All right, this video is coming per request of one of my viewers, so thank you very much for requesting that. We're going to get into some trig graphs today. So the basics of trig graphs, you're going to want to know what that parent function looks like, and I'll just be honest with you, this is one of those times in math, you got to memorize them. So there's three of them for you to memorize: sine x, cosine x, and tangent x. We're going to hit all three of those, and then I'll do some follow-up videos as we start to manipulate them. Okay, sine x is what we're going to start with. The first thing you need to understand is sine will go right through 0, 0 when we're talking about that parent function. Now, every 90-degree increment, you're going to hit a maximum, then you're going to hit an x-intercept, then you're going to hit a minimum, and then back up to an x-intercept. So I like to put a dot right here at 91, and then I know my next dot, my next 90 over, I'm going to be on an x-intercept. My next 90 over, I'm going to be at a minimum instead of a maximum, so now I need to be down at that -1. And then I go back up to an x-intercept again. So it goes x-intercept maximum, x-intercept minimum. X-intercept maximum would be over here at 450. I just didn't extend the graph that far. So let's look at what this comes out looking like. A lot of people talk about it as a wavelength. So you're going to go here and you hit your maximum, come back down, you hit the x-intercept, then you get a minimum, you come back and hit the x-intercept again. Then as you continue on, they kind of look like wavelengths. That right there would be sine. Okay, now the only difference from sine to cosine, which I'll do in a different color for you, cosine x, I'll graph that one in blue. The only difference is that you're not starting at 0, 0 like you are with sine, you're starting at 0, 1. So I can put a dot right there at 0, 1. And again, every 90 increment, I'm going to be going either down or up, down or up, down or up. So we start at 0, 1, and you're going to go 90 over, and that would be hitting your x-intercept. And if we started with a maximum x-intercept, our next one's going to be a minimum. So at this spot right here of 180, -1. So maximum, x-intercept, minimum, x-intercept, maximum. And the wavelength that you get when you go to graph cosine, it's going to end up looking like this. Okay, so sine x starts at 0, 0 and rises immediately. Every 90 increment is an adjustment from an x-intercept to a maximum, back to an x-intercept, then a minimum, back to an x-intercept. Everything's in 90s. You got to remember that, okay? Cosine, the only adjustment is we're starting at 0, 1, and instead of going up, increasing at the beginning, like you would with sine, you're decreasing down to an x-intercept and a minimum, then back up to an x-intercept and a maximum. And that pattern just continues on and on. We can just draw this continuing on to the right. You can even draw it to the left. I have a -90 here because I want to show you something when we get into tangent, okay? But those two right there are very similar. You just got to start studying and remember 0, 0 to start and rise for sine, 0, 1 to start and drop or decrease for cosine. Okay, so now that we've gone over sine and cosine, we need to talk about tangent, which does not look like a wavelength. It's not going to look the same as this. So sine and cosine, they can kind of go into their own little category. Tangent's going to look quite different, and we're going to have what are called asymptotes. I'll explain those to you in just one second. Let me erase what I have up here for you right now. That's what you're going to want to study. Once you have that memorized, my follow-up videos that I share with you will help you with where we go from here, because we're going to make adjustments to these, but we need to know what does the parent function look like. It's no different than learning slope-intercept form for the first time. You were taught slope-intercept form where it went through 0, 0, it went up 1 over 1, up 1 over 1, up 1 over 1, made a linear function, but then all of a sudden we started to manipulate it. We changed the slope, we changed the y-intercept, and you were able to be prepared for that. So I'm going to erase the blue and the black lines that I just drew, or graphs I should say, and then what we're going to do is we're going to go over tangent. So I'll just clean this up a little bit for you. And again, tangent is something you're going to want to memorize. So again, I would just make a chart in your notebook, study it regularly once a day, and then eventually you're going to have it dialed in where you say, I know exactly what parent function of sine and cosine look like, so that when we make small adjustments to them, you know what's happening. All right, tangents, our last one. So every 180 degrees with tangent, but starting at 90. So I like to tell my students in their notebooks, just draw a vertical line right there at 90. But now we're not going every 90 degrees as an adjustment. Now what we're doing is we're going every 180 degrees. So 180 added on to 90 is going to take you up to that 270. And again, the distance from positive 90 to negative 90 is 180. So every 180, we are going to have what's called an asymptote. I'll explain what an asymptote is in just a second after I draw it out for you, but let's dig a little bit deeper. So we are going to be starting at 0, 0 here. And what this graph's going to look like is it's going to go like this, and it's going to start to rise, rise, rise until it's going so fast up that it almost looks like it's going to hit 90, but it never will. It is never going to actually intersect with 90 for the value of x. It's just going to rise faster and faster and faster for eternity. Okay? Now over here, what it's going to look like is it's going to look like it's going to hit 90 going downward, but it doesn't. It gets closer and closer and closer and closer. Just imagine these two lines, right? They just keep getting closer and closer and closer together, but they never ever hit. So this graph goes like this. It increases. It hits the x-axis at 180, and then it goes like this and starts to increase very rapidly, and it will never hit the 270 mark. Okay, so never going to hit 90, never going to hit 270. Those are called asymptotes. Asymptotes means this value is never going to hit or intersect. Okay, and that pattern is just going to continue on. It's going to be very, very close, and then it's going to start to draw away. It's going to go right through 360, and then it's going to rise again at what number over here? Well, 270 plus 180, that would take me to 450. So we're at 450 there. There would be an asymptote also at 450. These are our asymptotes, and these are our tan functions. I don't know what's going on in that classroom, but tangent, that's what we're dealing with here. Tan x. Some people like to party. I like to get down to business. All right, so cosine. Again, where did cosine start? Try and remember from the beginning of the video. You don't have a picture up here. It starts at 0, 0. And then does it rise or does it drop? It rises immediately, so it's an increase, and it's going to have a maximum right there at 91. Remember, we don't go above 1 or negative 1 or below negative 1 when we're drawing the parent function out. So it's up, and then it's back down. Boom, hits 180. Comes back down and hits a minimum at negative 1 at 270. The next 90, it's going back up and hitting the x-axis there. So, sine off of 0, 0. Cosine, we already went over that one, starts at 0, 1. What's it do right away? Think back to the start of the video. Does it go up higher? No, it never crosses above the 1. Okay, it's going to go down to 90, intersect. And then it's going to hit a minimum at negative 1. Then it's going to go back up and hit an x-intercept. And then it's going to hit a maximum again at 360. So study each one of those three. I'd print them out or just write them out in your notebook so you have something you can go to and study each night. Once you get the parent functions dialed in and understood, have them memorized, everything else from there will start to become a lot easier. I'll have follow-up videos on this. We'll start to mess around with them so that you have a strong understanding of your trig graphs. Study hard and good luck on your upcoming test.